Hey guys, today we're going to go through three LeetCode questions in the span of 52 minutes and 30 seconds. Maybe I'll be able to solve it faster, maybe I'll take the whole time, won't be able to answer all of them, but this will just give a faster pace, faster average, closer to the amount of questions on average that and time that Facebook's and a lot of these other companies expect you to answer these. So that's usually around 17 and a half minutes or two questions for a 35-minute portion of your interview. So let's get started. Okay, first question. This is a very popular interview question called number of islands. Given a 2D grid map of ones, which equal land, and zeros, which equal water, count the number of islands. An island is a group, is a An island is surrounded by water and formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So I'm a little familiar with this question. I think thankfully for this question, you only have to consider um, the horizontal and vertical adjacent nodes. So instead of having to do eight nodes that you have to check, so checking the diagonals to the top left and top right, and the bottom left and bottom right, you only have to check four. So it actually makes it a little bit more simpler to write the code for that. And then when you look at a 2D matrix, one of the things that you can kind of automatically consider is, hey, is this a graph problem? And if so, is it possible for me to use breadth first search or depth first search? So for this, a lot of the things you're going to be doing is just like seeing how deep in the path you can go before you reach like a wall. So almost think like a maze. Okay, I can go this far until I hit a wall. In this case, what we're counting is the ones, and to make sure that if they are adjacent, like this one and this one, that all creates one island. And then if you look at this example right here, with these ones, that's one, and it's kind of separated, even though this is diagonal, that's considered separation. And this island, since it has neighbors of only up, right, down, left of zero, it counts as its own distinct island. And then finally, this bottom right, even though it diagonally to the top left has one, again, that doesn't count as a connected component or connected area of land. So I think I kind of thought like maybe it would just make sense to do breadth first search like level by level. So from there you can kind of just check all the adjacent nodes. But I think it makes more sense for this type of problem, especially with the path you check, just to do depth first search and then have like some sort of array of positions that you can use. Like yeah, so this is gonna be depth first search. I think you could do it either iteratively or recursively, whatever makes most sense. In our case, it might be better just to do recursively. Um, if you wanted to do iteratively, you would just use a stack to keep track of the nodes you're checking. And then we'll also want to, so we're not like visiting the same place over and over again. We'll have a corresponding visited or seen matrix the same size as our input that says, hey, have you already visited, let's say you're at the first element, have you visited this? Okay, then just skip that. Have you visited this component? No. Okay, then run our depth first search. So I think that's everything in a high level overview. And I think we can, oh, one more thing. The final part is like within your depth first search, like the different possible up, right, down, left. Let's say you're at one of the boundaries. So here you're at the top row, right? So if you do up, it doesn't exist because it's actually outside the boundary of the 2D matrix. So we'll probably have some type of helper function that makes sure that any potential node we check is within the confines or bounds of this 2D matrix. In this case, this is, I believe, a 5 by 4 matrix. And then the row length is 5, and then the column length is 4. Okay. And then how do we keep track of row and column? So for row, you can capture that length by matrix 0, I believe. And then let's see, do we want to keep -1? Okay, well, let's just keep that for right now. And then call equals lang matrix, so that's like the length or the total amount of rows, -1. Then we're going to create a visited 2D matrix, and we're going to use a list comprehension. So list comprehension in Python, that's just a easy way to basically, like, within these parentheses, just use a for loop to construct your own array instead of just having to like do it in multiple lines. In Python, you have a nice little one-liner there. Okay. So this first one I believe is going to be rows. So let's just say false. So hasn't been visited for x in range row. Then maybe, actually, let's just keep it like that. I gotta make sure I'm careful with like these bounds, but I believe you just want this range because I'm not sure that I think the last number is non-inclusive, so I think you want to go up to that. And then for y in range call. Then just to do sanity check, we're going to see it's the same dimensions as our input array. Oh, I always do this these types of problems. I just immediately think matrix and then type it out like that. Okay, let's see. Yep, 5 elements in a row and then 4 rows. Perfect. Okay. Yeah, 5 elements. Yep, perfect. Okay. So then what we're going to do next is we're going to do a nested for loop to basically get the indexes. So what you're going to want to do is start at index 0, 0, so the top leftmost entry point of your matrix. And then we're just going to iterate through every single possible element in the first row. If it equals 1 and it's not been visited, then you like run our DFS helper function. So actually, let's do DFS, which we'll call in a bit, which I believe is going to have RC. Yeah, let's do grid, then visited, pass, and then inbounds, which was our helper function we mentioned earlier. That's going to be, let's see, probably the same thing. Grid. And then for this, like we just want to say, like, I think that's something simple like return 0 greater or equal to R, which is less than the length of grid 0, and same thing with the column. So 0 is greater or equal to C, which is less than length grid. And then we want to make sure that this has not been visited. So we want to make sure it exists, right? And grid RC and not visited RC. Okay. And then within DFS, actually, let me just do this first. So for R in range row, for C in range call, if visited RC, continue, else self, I'll be calling this on both, so self.dfs. Oops. Poor habit of like just keep on using like ij nested for loops. Okay, yeah, focus is very important with these type of problems. So RC grid visited. And then from here, oh yeah, you're also going to want a count variable, because you're going to want to return the total amount of islands you find. And then we're going to return count at the end here. At the, if you pass this has not been visited, and this equals 1, yeah, if grid RC equals 1, then you do a DFS. Then you do count increment by 1. Okay, now I gotta track when it's been visited. Okay. So you only have 4 directions, so basically, let's do this. Let's just do like a simple list of tuples. So from that, we're going to do up, right. So up from the x coordinate, I don't think you do anything. You just do the column coordinate. That's usually -1. So you do that. Right coordinate, you don't do anything to call. You just add by 1. For down, you basically just add by 1, and then for going to the left, you subtract the row by 1. Okay. And then like when we use these directions, we'll we're going to iterate for these directions for now. I just got to make sure like where I can update this visited RC. So I believe, okay, so you'd call it before this. So maybe I don't need this visited RC. Oh, okay. It's for these other ones. Okay, yeah, so I'll just do it right here. Okay. And then here we can just iterate for these tuples. So now I'm checking if self dot inbounds. Well, actually, let's make it more descriptive. Within matrix. Okay, within matrix. Then from here, we have R plus direct 0, C plus direct 1, grid. Oh, actually, we might have this visited statement on our first DFS. Okay, yeah, let's do that. Because like when you recursively call this DFS down here, you're gonna want to mark it as true. Okay. Visited. Okay. If that's true, then you do a self.dfs, and then you just copy these basically. Okay, let's check how we're doing on time. Okay, so 52. Okay, I'm getting close. I should start checking this first problem. Okay, so these make sense. We already checked visited, count. These look good, I believe. If visited, if that's true, then just continue to the next one. Um, or so we should do it if 0 2 or grid RC equals 0. So just continue there. Okay, so on this DFS, this is what we're marking true. So for this first one, it'll go here. It'll mark that first node as true. Then it's going to go through its directions, which is up, right, down, left. Within that, check if it's within bounds. And then these are like, hey, this is the row bounds. This is the column bounds. And make sure that this is actual point within the matrix too. What if that's 0 though? Oh, if that's 0, then it just return false. Perfect. And oh, so I don't even need this right here. They'll just check it for me. I'll just keep it there, and then not revisited RC. So yeah, let's run this. Oh, okay. So let me just. I knew I was gonna get in some form of trouble with uh, these ranges. Okay. Where did I goof on this? So grid RC equals 1. Okay, so you call DFS when it equals 1. Self.dfs, make that true. Self.dfs, within matrix, self.matrix, self.dfs. Okay, I'm using self, right? Okay. These grids are right because you do want to go to the element 1 minus it. Grid equals 1. So what's going wrong here? Zero. Oh, okay. Not less than. Greater than. My bad, guys. Hmm. Oh, no, no, no. I was right. Because C and R are greater than that. Okay. Okay. I need to wrap this up really quickly. I think I'm getting caught up in here. Somehow this is not running correctly. So maybe I do just... Alright, what happens if I change this right here? Okay, nothing changes there. Okay, how about this? Does not equal 0. That's what this is supposed to prevent. Okay. Okay. Oh no, I got it wrong. Okay, let's try that again. Interesting. Okay, I'm gonna have to check into. I feel like a majority of the issues right here. Like I'm getting lost somewhere in these indexes. Directions check. I don't understand why these are out of bounds. Maybe this is it. Okay, I'm getting confused with these indexes. I'm going to check that, but for the most part, I think this structure is good. I really like being able to use like tuples and lists there for the directions. Let's say you wanted to do like all diagonal directions, then like for example, you want to say like up and then to the left, then you would do something like this: -1 for x or row index, and -1 for column index. So that's one way you can just easily, like, you just have to change one line of code, and then this code will still work using just a simple DFS and within a matrix, or like basically kind of like a like is in bounds helper function. So I gotta check in like why again this. Maybe it's just as simple as I actually just switched these on accident. Check. Okay. No, okay, there is some issue I had to figure out here. Okay, so let's go to the next one, spiral matrix. Okay, I've been dealing with a couple of these like 2D matrix problems, and one of the things I've learned is if they tell you to do like a specific pattern, it's going to be a lot of like specific traversal that you have to use with iteration, and then it has to be within bounds. So you can also do like a zigzag matrix, and basically it's a bunch of like ugly code. But yeah, let's go through there. Let's see how much time I have for this one. Oh, okay, I gotta speed up. All right. Given, this is question number 54 too. Given a matrix of m times n elements, m rows, n columns, return all elements in spiral order. Okay. I think something like you could do is basically if you just look at like logically, like okay, start at 0, 0, go all the way to the bound, okay, then you just increment by 1 and then go to the bound, and then you increment by 1 from, or minus by 1 from this last column, and I mean decrement by 1 from the row index because you don't want to double count the items, and you just keep on doing that. And then I think you have a safety check that you don't do a previously visited one, or you kind of just subtract that index, and then you keep on doing that, and then it works for larger matrices too because it just follows the same pattern. So it's gonna be a bunch of while loops. It's gonna, and I've seen this problem too, but it's a little bit fuzzy for me. But I believe it's gonna be on time. Oh, actually, no. Since this is row and columns, it's gonna be on times n time. And yeah, oh, actually, you're just counting the elements, so it would be O of n time. Space, it's yet to be determined, but yeah, let's work on it. Just gonna be a couple indexes that you keep track of and all the directions, and then you probably just change the direction using just some type of enum or like string. So let's go from there. See left, right. Oh no, top and bottom would be. Okay, let's do left, right first. So you're basically just going to the ends of a row, right? Trying to see how to. Okay, I know there's gonna be a while loop though, so let's just do that. And within that while loop, you just do like some simple iterations for like each different direction. So let's say direction equals right. So I think I'm just gonna have this. Yeah, left and right makes sense to me. Actually, row and column makes sense to me. Let's see. For this, like I want to say it's like less than certain numbers. Oh, and then we want to output, of course, so it would be oven space. So I believe this will be O(n) time, because you're really just counting the numbers. I know you're kind of doing m times n traversal, but you're just really iterating and then capturing that one by one. and then O and space. So from there, let's see. Okay, so let's say that's left. We're going to go all the way to right. Top to bottom. Okay, yeah, let's just do left, right, top, bottom. I think that's it. Next one. And then top equals 0. Then bottom equals lang matrix -1. Okay. First direction right there. Yeah, okay. So while left is less than or equal to right, and bottom oh I guess we could have that be, yeah, okay, let's do that. Oh no, sorry, top is less than or equal to bottom. Okay, now this is where we do our code. So if direction equals right, boom. And we're just gonna have 4 of these. Okay, this will be down, oops, left, up. And from there, after you go for your iteration, you're gonna have direction equal down. I kind of just copy the same process. You're basically just like switching direction after you iterate for everything. And then like eventually your left or top index is going to be greater than the bounds because you're going to be subtracting the bounds at the end of it too. So it gets smaller and smaller. Like your spiral gets smaller and smaller, and it's gonna like basically like the snake game, eat itself. Okay, so from there, for I in range left, I think from here, then you just do output dot append matrix I, because you go from 0, 0, 1, 2, 3, or 0, 1, 2. And then your top just remains the same, which is 0. And then from there, at the end of it, I think you also do top plus 1. And how do we keep track of... So maybe it's less, and then like right here in the range we could... Okay, let's try that. Plus 1. Okay, I think that's it. And then because you add this plus 1, you don't have to duplicate it. Then from down, you do from j in range top going to bottom plus 1. And then from there, you do output dot append matrix. And then from here, you just do left. Then from here, you do j. And top gets added by 1 each time. And then at the end of it, you want to do right minus 1 because you don't want to replicate that. Oops. Oh, okay, no, you can do that out. Yeah. Direction equals... Oh, you already had that. Okay, forgot I wrote that. Okay, and then kind of same thing. Now this is where it gets tricky, I believe, because you have to do it in reverse. And I believe when you want to go down, you want to go all the way to 0, or basically like -1. So for W in range, what is this? This is going to be left. Oh no, this would be right to left -1. You increment it by 1. Output dot append matrix W, and then from this we have the same top. I believe. Okay. Then from there you want to plus the bottom by 1, right? No, you want to subtract it by 1. Then from here, you want it to go for x in range bottom to top -1. -1. Then from that, output, append matrix, and then from what we were at, we were going to be at left, right? Okay, I think I mixed up the matrix indices here, but I definitely know X is going to be right here. So for here, maybe we don't want to decrement. Oh yeah, no, we want left, okay. All right. No. Okay, so we don't decrement here. It's fine. Okay, so we don't need to increment because we just use right on the next one. Okay, let's try this out. Okay, let's make sure I didn't make any other silly mistakes. Index out of range, okay. Let's go to this. Let's see how much time I have here. Okay, 9 minutes. Okay. Let's see where this goes wrong. 1, 4, 7, 8, 9. Oh, 8, 9, 5, 2, 2, 5. Wow, that's interesting. Okay. So I think I kind of got it to work. I just mixed up the indexing here, so I got to look at this very carefully. So I'll get back to this one. Let's go to the next question. See if I can quickly do this. Insert interval given a set of non-overlapping intervals. Insert a new interval into the intervals. Merge if necessary. Assume if the intervals were stored initially, sorted according to their start times. Okay, perfect. So let's do output equals intervals 0. So the reason I'm doing this 0, I'm kind of somewhat familiar with this problem, and I know it's just best to start with like a already initialized element. So for example, if 1, 3 is there, then you can check, you can actually check within intervals if your next item, those ranges, so say 6 and 9, is this between or greater than these numbers? So it's easier to do that. k, and then index equals 1. Okay. So maybe I don't need this one. If So what I'm doing here is I'm just checking this simple case to append. In this case, if these numbers are outside these bounds, so 6 and 9 are out of that, then you just append it to this list. Boom. So let's see. Oh, but I need to check every single interval in this list because even though 1 and 3 might not be, 6, 9 might be like in here, for example. Okay. For elan in output, then out here, if R0, R1, so this, output append. Oh, so you need a checker. Because like, yeah, if you update something, combine it, then you want to check that next one and make sure it can combine so you can consolidate. Ooh, okay. Let's see, what can I do quickly? Okay, I think it might just be easier to do the simple check if it's not there, append, and then if you find something, you can always consolidate on the way back. Yeah. Okay, if I put -1, -0, then output -1, 1. Actually, let's just do variables. Start and if start if R0 is less than greater than start and R0 is greater than end and R1 oh, okay, the same thing. So maybe to make this simpler, yeah, just have that be in between. And the opposite too. So either it's less and start is greater than R0 Okay, let's just try to wrap this up. So for this, start is greater than 0, and then so is end. Okay, and I basically just have to do this one for R12. Then I want to see that appended. Okay, so let's just see if that works. So from here, output dot append R, and then yeah, let's just print output. Okay. Oh, new intro. Oh yeah, and I can use that as like a placeholder variable. Okay, I gotcha. Okay, I need to read these questions, but yeah, this is actually a pretty good problem. I'm gonna look at all of these. They're like little one-off errors, getting closer, but yeah, just gotta have to keep on doing practice. Thanks, guys, and I'll see you in the next video. Cheers.